Let's start the new chapter, which is chapter number 15, probability. It is the last chapter of the mathematics. Now, what are we going to study in this chapter? Probability, you have already studied in grade 8, right? You were finding the number of outcomes, then total number of outcomes. So, it's all about that. First of all, let's start with few definitions that is important to understand the concept of probability. First of all, probability itself. Probability, study of the chances of the events happening. Why are we studying it first of all? Right? The reason we are studying, we want to know that what are the chances of something happening in the future. Suppose you take about the match only, your favorite team. Is it going to win or lose? We always keep thinking. That's the reason we watch the match, right? And we want to know 50% chances, 60% chances, 90% chances, 0% chances, or maybe 3% chances as well. So it's all about that. We want to know about the chances, that is it going to happen or not. Suppose you talk about the rain. Is it going to rain tomorrow? What are the chances? 10% chances, 0% chances, 70% chances, right? So this is all it's about. We want to know, we want to get an idea that is it going to happen? What are the chances that it is going to happen? So it's all about probability. Chances, it's all about chances. What are your chances of winning the game, right? So we talk like that. Next term, it is experiment or trial. Operation which can produce well-defined outcomes. Okay, we are talking about the operations which has well-defined outcomes, means whose outcomes are already defined and we know very well. Just talk about the coin. If we toss a coin, we know either head will come or tail will come. We don't doubt it, and it is clear that either head will come or tail will come and nothing else. The outcomes are well defined. We already know beforehand something of this will only come. We are sure of it. Nothing like at the end of the experiment we come to know that there is something new that we did not expect. That's not about the probability. We have already well defined outcomes. Now, experiment or trial can be of two types, random and deterministic. Now, there are so many kind of things that whose outcomes we do not know. Let's take an example again of the coin. If you toss a coin, you don't know will it be head or tail. So, whose result is not same every time, right? So, random experiments are like that. Do not produce the same outcome every time. Every time you toss the coin, outcome will be different. So, that's about the random experiment whose outcome is not decided, while deterministic experiment or trial is completely opposite, produce the same result, right? However you try it, but the result will be same only. Next, event. Now, what is event? So it is possible outcome or combination of outcomes. That let's talk about, we toss a coin and we want to find the probability for the head. So head is an event, right? Possible outcome. Okay, any of the outcome can be the event, or if we combine many outcomes, that can also be event. So event is possible outcome or combination of outcomes. Now let's talk about the probability itself. Probability experimental approach. Now there are two approaches for the probability: theoretical approach that you discuss in grade 8 and experimental approach which we are going to discuss in grade 9. Now what's the difference? In the theoretical approach, we have the formula, we think of the situation, we identify the possible outcomes, we talk about the favorable outcomes, then we find the probability. But in case of experimental approach, suppose we have coin again, and if we toss that coin 500 times, remember we toss that coin 500 times. Let's write here 500 times we toss the coin. So 200 times heads is coming and 300 times tail is coming, right? So this is called something experimental. We have this true result after the experimentation. We toss it 500 times. Then we come to know that there are 200 times heads are coming and 300 times tails are coming. Now, if we want to find the probability from this one, what do we do? Favorable outcomes, right? Okay, let's talk about head. If we want to find the probability for the head, that's very simple. 200 divided by 500. Previously we were having only 2 outcomes for the coin, but here we have 500. But remember, it's about the experiments. We have run that experiment or trial 500 times, and this is the outcome. We get it 200 times head, 300 times tail. So this is the formula for the probability of any event E. Number of times in which the event E has occurred. Okay, how many, suppose if we want to find the probability of head, how many times head occurred? 200 times, right? And in the denominator, number of times the experiment has performed. How many times did we perform the experiment? 500 times. So if we want to find the probability, we can write here probability of head is equal to 200 over 500. So 0, 0 get cancelled, and 2 by 5 is the probability, right? Very simple. But don't get confused at why are we getting 500 outcomes for the coin, right? The reason behind, it's not about the outcome of the coin, but it is number of times we perform the experiment. It's all about experiment. Remember, that's why it is written experimental approach. Even if we talk about the die, we can also toss die 500 times. We can get 6 different outcomes and we count it. This is coming 100 times, then this is coming 150 times, 200 times, and so on. And then we can find the probability. So this is the idea behind the experimental approach. We have experimentation, we have done the experiment, then we have some data. From that data, we find the probability. That is the experimental approach for the probability. Remember, number of times in which the event E has occurred, 200 times in this case, and number of times the experiment has performed. How many times did we perform? So it's all about the probability for the experimental approach. Now let's discuss few properties related to probability. The first and most important is probability lies between 0 and 1. It can be 0 as well. If it is 0, then it is called impossible event. Means it is not at all going to happen. There is no chance that it is going to happen, right? Next, if it is equal to 1, probability equal to 1, it is called sure or certain event, right? It is called certain event, sure event. It is going to happen 100%. Sunrise in the morning, right? That's a sure event, right? So that is called sure event, and probability is 1. If it is 0, then impossible event, probability 1, then sure or certain event. Now, any value between 1 and 0 is accepted for the probability. Any value between 0 and 1 is also accepted, and 0 and 1 as well. Next, sum of all probabilities of all possible outcomes of an experiment is 1. Means, suppose you take head and tail, tossing a coin, right? Probability of head is what? Let's write here that probability of head we know very well. That's 1 by 2. Probability of tail is 1 by 2. And if you add both of them, 1 by 2 plus 1 by 2, that's 2 by 2. So answer is 1, right? This is the probability of head and this is the probability of tail, right? So if you add them, if you add probability of each outcome, you will get answer as 1, right? If you have more outcomes, then you can add one more probability, though you will get the answer 1. Next, now there are chances that certain event is going to happen and certain event which is not going to happen. Okay, let's say the chance of winning the match is 60%, right? This is the chance to win the match. Now, to lose, it will be what? 40%. How do I know? Subtract from 100. It is about percent. Now, when we talk about in the general sense, we consider it as 1 because we know maximum probability could be 1, right? So, if we want to find the chance of not happening that event, then you subtract from the 1, right? if you have probability 1 by 2 and if you want to find the chance of not happening, subtract from the 1, so you will get that chance as well. So these are the 5 properties. These first 3 are very important. 1 mark questions are possible. That what is the probability of impossible event or certain event. Now let's discuss few questions related to probability. Let's start with the questions now. First one. 3 coins are tossed simultaneously 200 times with the following frequency of different outcomes. Find the probability of getting 3 heads, no heads, at least 2 heads. Okay, so we have total number of trials. What is the total number of trials over here? How many times we have performed the experiment? That is 200, right? So let's write number of trials is equal to number of trials is equal to 200. Important point. Then what we need to find the probability of 3 heads. So probability of 3 heads. Let's start. Question mark. How can we get it? So denominator is fixed, that is 200, right? Number of times we have performed the experiment. Then we have the table over here. Now see, it's given over here outcomes and frequency. How many times 3 heads are coming? 23. Very simple. We are interested in finding the probability of 3 heads. So we only take the outcomes related to 3 heads. That is 23. 23 by 200. Now 23 is the prime number, right? So we won't be able to do any kind of cancellation. So this is the final answer. First one. Now let's move to the second one. Probability of getting no heads. Okay, so no heads. That is question mark here. Again, in this case, denominator will be 200. No doubt in it. The reason behind that trial is going to remain same, 200. Now we want to find the probability of 0 head. Now you can see that is 22 outcome for the 0 head. Now let's do cancellation. Both are even number. So here 11s are, here 100s are. So 11 by 100 is the probability of getting no heads. And the last one. So probability of getting at least 2 heads. Okay, let's write at least 2 heads. Now question mark. Very interesting question over here. Why we cannot directly take the 84? Let's understand the reason behind that. Because of the word at least. You must have heard this word many times. At least you should get this one, right? At least 20 marks lele, right? 20, at least minimum 2 heads. Now minimum 2 heads means what? Let's write minimum 2 heads. Minimum we want this one, right? So it means that can we go below it? No, it's not possible. Minimum इससे नीचे नहीं जाना है, ऊपर आप जा सकते हो, right? So minimum 2 heads means what? We can take 2 heads, then 3 heads. Are we having 4 heads over here? Not possible, because we are tossing only 3 coins. So what are the outcomes for the 2 heads? That is 84, and outcomes for the 3 heads, that is 27. 7 and 4, 1 over here and 1 carry over. So here 1, 1. So what is the probability? 111 by 200. That will be the probability of getting at least 2 heads. Remember the logic behind this question. This is very important. It's all in the meaning of at least. At least means minimum 2 heads. 2 heads are accepted. Maximum depends on the conditions which are given over here. That we can have only 3 heads, not 4 heads, because we are tossing how many coins maximum? 3. So 2 heads, 84. 3 heads, that's 27. Now if you add up, you are going to get 111. Total number of trials are going to remain same, that is 200. So 111 by 200. Let's discuss what we did. Number of 3 heads. Okay, probability of getting 3 heads, 23 is the outcome, divide by 200. Then number of no heads, probability of getting no heads, that is 22, given in the table only. So 11 by 100. And probability of getting at least 2 heads is 111 by 200. Let's discuss next question. Let's discuss one more question related to coins. Let's start. 2 coins are tossed 1000 times and the outcomes are recorded as below. Number of heads given 210, 200, 550, 250. Find the probability for at most 1 head. Okay, first of all, let's write number of trials. How many are there? 1000. So, number of trials is equal to 1000. So, probability of at most, what's given? At most 1 head. Again here, previously the case was at least 1 head. Now here, at most 1 head. So let's understand the meaning of this word, at most. So at most means maximum 1 head. It means that we cannot go more than 1, right? 1 is our limit, that's it. But lower than that, yes, it is accepted. So we need to take 0 head and 1 head. This is what we need to take. 0 head. What is the frequency? That is 250. And 1 head. What's the frequency? 550. And here, let's add them up. 0, 0, 1 and 800. So, what is the favorable outcome? 800. Now, let's proceed for the probability. So, probability will be what? 800 divided by number of trials, that is 1000 in this case. So, 0, 0 cancel. Here, 8 by 10, 2 4s are 2 5s are. So, answer is 4 by 5. That's our answer of probability of at most 1 head. Now let's understand the meaning one more time of this word, at most. It is maximum 1 head, right? So we will be accepting 0 head as well. We cannot go more than 1 head. Till 1 head, everything is accepted. So frequency for 0 head is 250 and for 1 head is 550. As we are talking about maximum 1 head, we accept 0 head, 1 head, add them up. So that is the frequency for the outcome, 800. Divide by number of trials, that is 1000. So 800 divided by 1000, after we do cancellation, we'll get 4 by 5. So this is the probability of getting at most 1 head, that is 4 by 5. Let's discuss one interesting question related to coin and ratio. Let's start. A coin is tossed 100 times with the following frequency. Head is coming 36 and tail, it is coming 64 times. Find the ratio of probabilities for each event. Okay, now what we are supposed to do? We need to find the probability, we need to find the ratio of the probabilities of each event. So if we get the probability for the, basically see what we need to do, ratio is equal to probability of head by probability of tail. This is what we need to do. So first of all, let's start with probability of head. Here, number of trials are going to remain same, that is 100. And how many times head appear? That is 36. Now wait here, don't do cancellation. Wait that only. This is the beauty of the ratio. Next, probability of tail. So number of trials are 100 and tail is coming 64 times. Keep it as it is. Now come to the ratio. We want to find the ratio. So ratio, we need to put probability of head into numerator. So 36 by 100 and here 64 by 100. Okay, now see, we can do one thing over here. Denominators are same, so get cancelled and we are done there. Or we can even bring this 100 down and this 100 in numerator for better understanding. So let's do that one. So 36 in numerator, this 100 will come up, so 100, then this 100 will come down, so here into 64, 100 cancel. Now 36 and 64, here 4 9s are and 4 16s are, so 9 by 16 or 9:16 is the ratio of the probabilities of each event. So let's recall what we did. We have the number of trials 100, heads are 36, tail are 64. We need to find the ratio of the probabilities, not only probability, right? We know how to find the probability. Get to probabilities, then write the ratio. Simplification plays very important role, right? Do the cancellation and get the ratio, which is 9/16. Let's discuss next question. Let's discuss one more interesting question. So let's start. A coin is tossed 100 times and head appears 64 times. Let's write this information. Number of trials is equal to 100 and head appears how many times? 64. So head is equal to 64. Now what we need to find? The probability of getting a tail. We need to find the probability of getting tail. Now this is interesting question and easy as well. You just need to think in a proper way. Let's say there are 100 outcomes, 100 times 100 is the trial and head appears 64 times, then how many times tail is going to appear? Think of it. It's very simple logic. That is what? 100 minus 64, right? That is 36. Very simple logic you need to keep in mind over here, right? If head is coming 64, remaining time it will be tail, because for the coin there are only two outcomes, head and tail. Now to find the probability, we need number of frequencies, that's 36 for the tail, and total number of trials are 100, so 36 by 100 is the answer. So let's mention it, then we are done. So here probability of getting tail is equal to 36 by 100. So here 4 20 5s are 4 9s are, so 9 by 25 is the probability of getting the tail. Very simple logic. The case we discussed, reason behind was that we were not having number of outcomes for the tail. We had for the head, but probability was asked for the tail. That's why we discussed this question. Interesting and easy as well. So let's see what we did in this question. We have the number of trials 100, number of heads 64, so remaining will be what? Tail only. Very simple logic. So subtract both of them when we get the number of outcomes for the tail, that is 36. Probability means what? Outcome by number of trials. So how many times tail is coming? 36. So in numerator, then number of trials, that is 100. So substitute, can do cancellation and get the answer. Now let's discuss the case of dice, right? Dice we use to play snakes and ladders and Ludo as well. We know what is dice. It has 6 faces, right? On which there are numbers from 1 to 6. 1, 2, 3, 4, 5, 6. Right? So we are discussing questions related to that. Let's start. A die tossed 200 times simultaneously and the frequencies of various outcomes are given below. So 1, 2, 3, 4, 5, 6. The probability of getting 5 is dash. We need to find the probability for getting number 5. Let's start. So first of all, number of trials. So number of trials is equal to 200. And what we need to find, probability of getting 5 is question mark. This is very simple question, nothing much to do over here. We just need to see how many times 5 is coming. Frequency is what? 65. So just let's write it. That's very simple. So 65 over 200, right? Now 65 and 200 both are divisible by 5. Why? Because I come to know on one's place there is 5 and 0, both of them, right? That's the condition for divisibility of 5. Here 5 13s are, here 5 40s are. So 13 by 40 is the probability of getting 5 for the given question. Very simple. Now it is possible that other question can also be asked framed based on this as well. Probability of getting 1 or 2 or 3 or 4 or 5 or 6, any of the number, right? So this is the most basic question for the case of die. Now let's discuss few other questions. Let's discuss one more question. A die is thrown 230 times and the results were as follows. Outcomes are 1, 2, 3, 4, 5, 6 and frequency is also given. We need to find the probability of getting prime number. Previously we discussed to get the probability of only one single number. Either it could be 1, 2, 3, 4, 5 or 6, any of it. We discussed for the 5. So first of all, let's start with number of trials, that is 230. So number of trials is 230. Now what we need to do? We need to find the probability of getting prime number. Okay, so on the dice there are 6 numbers, 1, 2, 3, 4, 5 and 6, right? And we are supposed to get the prime number. So which are the prime number? Can I say 1 is the prime number? No, it's not. 2 is there, 3 is there and 5. So what are we going to do? We need to get the favorable outcomes, right? So for the 2 it is 50, then for 3 it is 16 and for 5 it is 24. So let's add all of them. That is what? 90, right? This is the favorable outcome. 90 is the favorable outcome. Remember, we are supposed to talk about prime number. Don't take 1 there. 1 is neither prime nor composite. So 2, 3 and 5 are the prime numbers. Take their outcomes, add them up, as we want to only find for the prime numbers. Now let's get the probability. So probability of getting prime number is, first of all, what will be in numerator? 90. Denominator, total number of trials, that is 230. 0 get cancelled. Now 23 is a prime number, so we cannot do any cancellation. So this is how we find the probability for the dice of prime number. Now how this case is different than the previous one. Here we are talking about property of numbers. Maybe even number is possible, maybe odd number is possible. Like prime numbers are possible, composite numbers are possible. So this is all about the properties of the number. And the same concept is mixed with the probability. So this is how we find the probability of getting prime number when we have frequencies given to us. Let's discuss one more question related to die. Let's start. A die is tossed 300 times and the results were as follows. We have outcomes 1, 2, 3, 4, 5, 6 and the frequency, right, for all the numbers. And what we need to find the probability of getting either 1 or 3. Okay, so first of all, let's write number of trials, that is number of trials is equal to 300. And what we need to find probability of either 1 or 3. 1 or 3 question mark. This is what we need to find. Okay, so let's see how do we approach this one. First of all, frequency of 1 or 3 we need to find. That's right. Frequency of 1 or 3. This is what we need to find first of all. We need to get the frequency of 1 or 3. Now, the reason behind discussing this question is to understand how to deal with this situation when we have OR in the question. So, first of all, let's get the frequency of 1. That is what? 4040, right? And frequency of 3, that is 60. Now, whenever we have 1 in the question, what we need to do? We need to add the frequencies. Frequency of 1 plus frequency of 3. So, total we are going to get 100 as the frequency for this outcome, right? 1 or 3. Very simple it is. So, let's get the required probability, 1 or 3. So, what is the favorable frequency? That is 100, and total number of trials, that is 300. So, 0 and 0 get cancelled. So, that is 1 over 3. So, that is the probability of getting either 1 or 3. Now, similarly, you can have combination of 2 or 3 numbers as well. 1 or 2 or 3, right? If we want to have 2 as well at some point, so we can do that as well. Let's start with that just for the purpose of understanding. Let's get 3 numbers here. Probability of 1 or 2 or 3, right? We want to find this one. So here as well, we'll get the frequency for each of them. For 1, for 2 and for 3. So for 1 and 3 we already know, that is 40 and 60 here. And for 2 it is 65. So it is 165. This is what we get, favorable frequency. Now for the probability, let's write in the form of fraction. So that is probability of 1 or 2 or 3, that is 165 over 300. Done. So we can use table of 3 here. I believe that's hundreds, right? Here 5s and 5s here. Okay, 154. Again we 55. We can do cancellation again. Here 5 20s and here 11s. So what's the final answer? That is 11 by 20. Right? So this is the probability. The basic idea, again I'm repeating, is to understand how to understand the meaning of the word OR and how to do the calculation. Here we had only 2 numbers. I've just taken one extra number for the understanding. 2 numbers, you get the individual frequency, add them and get the probability. Here 1 or 2 or 3, right? You get the frequency, individual frequency again, add them and get the probability. So this is how we deal with the sum when we have OR in the question. So far we discussed the questions related to coins and the dice. Now let's discuss miscellaneous questions that we are going to start from this session onwards. Let's start with the first question. On a particular day, the number of vehicles passing through a crossing is given below. Okay, vehicle and frequency, right? 2-wheeler, 3-wheeler and 4-wheeler, 57, 33 and 30. Okay, a particular vehicle is chosen at random. What's the probability of it is not a 4-wheeler? Okay, so we want to find the probability that it is not 4-wheeler, right? So first of all, let's start number of vehicles. So number of vehicles is equal to, what's that? It's not given over here, right? Interesting. So how can we get the number of vehicles in this case? Okay, see, we have 2-wheeler, 3-wheeler and 4-wheeler. So 2-wheeler, 3-wheeler and 4-wheeler. Let's note it down. 57, 33, 57, 33 and finally 3, 0. So here 0, carry over 1, 3 and 3, 6. Okay, 12 it is, 120. So number of vehicles are 120. That's done. See, this information was not given, but we are supposed to find it, right? So this is important step before we move on. Now we want to find probability that it's not 4-wheeler. Okay, probability of not 4 wheeler we need to find. So if it is not four-wheeler, then it will be what? Two-wheeler and three-wheeler. That's very logical. If we don't take the four-wheeler, we are only supposed to take two-wheeler and three-wheeler. So let's write number of two-wheeler and three-wheeler. That's addition of it. So 57 plus 33. That's what? 90. Very simple, right? Remember, we don't want four-wheeler. So we are accepting two-wheelers and three-wheeler. That's a very logical question. So let's find the probability. So probability of not four-wheeler is equal to, so what is the favorable? That's 90 and total vehicles are 120. 0, 0 here. 3s are and 4s are. So 3 by 4 is the probability of vehicle not four-wheeler. Very simple it is, right? In this question, we were not having total number of outcomes, basically trials we can say, or in this case, total number of vehicles. So what did we do? We added all the information, all the frequencies that we were having. So to get the total, that is 120, right? Afterwards, we were not interested to find we wanted to find the probability of not four-wheeler. So we can take two-wheeler, then three-wheeler as well to find the outcomes for two-wheeler and three-wheeler combined. That's 90. So 90 over 120, that is 3 by 4 is the probability. Let's discuss next question. Let's do one more question here with the miscellaneous concept. Let's start. The table given below shows the marks obtained by 80 students of a class in a test with maximum 100 marks. Okay, so table is given over here, 0 to 20, 20 to 40 and extends till above 80. And number of students are also given, 8, 16, 40, 10 and 6. Now, a student is chosen at random. Find the probability that he gets less than 40 marks. First of all, we need to find probability. If we select one student randomly, that probability should be getting marks less than 40 and another 60 or more marks. Okay, first of all, let's write total number of students. So, total number of students, that is, how many are there? 80, right? That's clear, it's given. There are 80 students are there. First, we want to find probability of getting less than 40 marks. Probability of marks less than 40 is equal to question marks. First of all, let's get how many students get less than 40 marks, right? So in this category, 0 to 20 will be considered, that is 8. Next, 20 to 40, that is how many students? 16. So if you add them up, you are going to get what? 24. So 24 students are there who are getting marks less than 40. Now we want to find the probability. So we have the number of students who are getting less than 40 and total number of students as well, right? So let's find the probability. So probability of getting marks less than 40, that is what? Here we have 24 students and total number of students are 80. So here 8 tens are and 8 threes are, that is 3 by 10 is the probability, right? This is very simple. You must be confused when you read the question that how to get the answer. But remember, see the question, marks less than 40. So less than 40, we only need to take only two groups frequency, that is 0 to 20, 8, 20 to 40, that is 16. Nothing more than that, right? Only need to focus on the data which is related to probability which is being asked. Now let's discuss another question. This is 60 or more marks. Okay, so we need to take probability of marks greater or equal to 60. 60 is also accepted and more than 60 also we want to find. Now first of all, let's find number of students who are getting marks less than more than 40, more than 60, right? So 60 to 80 is the first category, right? That is 10. So 60 to 80, that is 10. And next category is above 80. How many students are there? 6. Now add them up. So we are going to get 16 as the number of students who are getting marks 60 or more, right? Now for the probability. So probability of marks greater or equal to 60. That is, number of students are 16 and total number of students are 80. So 16 ones are and 5s are. So that is 1 by 5, right? First, we wanted to find probability of students who are getting marks less than 40. And here we want to find the probability marks more than 60. So these are the two different categories, right? First of all, we focus till 40 only. So first two category, then more than 60, 60 and more. So last two categories. So this is how we find the probability. Let's discuss one more problem. 1500 families with 2 children were selected randomly and following data were recorded. So data is number of girls, number of families, 2 girls, 10 point and 0. So we have number of families as well. What we need to do? Find the probability that our family chosen at random having 2 girls, 1 girl and no girls. Okay, so first of all, let's write total number of families. So number of families is equal to 1500. We want to find the probability with family with 2 girls. Okay, so probability of family with 2 girls is question mark. So let's start. So how many families are having 2 girls? We can see in the table, that is 475, right? Very simple. And total number of family is 1500. So 475 over 1500, right? Now see, both of them are divisible by 5. So divide with 5. Here, if we divide with 5, we are going to get 300. That's very simple, right? Here 4 9s are, 2 5s are. Here 60s are and here 19s are. So that's the answer. 19 by 60 is the probability of family with 2 girls, right? Because it's straightforward information, nothing to bother about. Now we need to find probability of family with 1 girl. So let's start. Again here, probability of family with 1 girl is equal to question mark, right? So how many families are having 1 girl? That is 814 and total number of families are 1500. Again, that's very simple. So 814 divided by 1500. Now both of them are even number, right? We can still divide with 2. So let's start. Here 750 and here 4s and 0 and 7. I think we cannot divide further than this. If you can divide, go ahead. So final answer is 407 divided by 750. So this is the probability of family with 1 girl. Now the last topic is about the with no girls. Okay, probability of family with no girls is equal to question mark. So 0 girls basically, right? That is 211. So 211 and total number of families are 1500. So that's the answer. 211, that's even number, odd number, and 1500 is even number. So that's why we cannot divide with 2. If we can try with the 3 as well, 2 and 2, that's 4. So 3 is also not possible, right? 5 is obviously not possible, right? So if you can divide, you can go ahead. I think we cannot divide further than this. So this is the final answer. Stop at that point if you cannot divide. If you can divide, go ahead. No, nothing to worry. So this is how we solve this question. Remember, it's all about how you interpret the information, right? With one girl, two girl and no girls, right? The table is given over here, right? Number of families are also given. We just need to select it. This is for the two girls, that is 475. For one girl, that is families are given. Number of families, that is 814, and with the no girl, that is 211. So this is how we find the probability. Let's discuss one more question. Let's start. The following table shows the daily earnings of 25 shops. So how many shops are there? First of all, 25, right? And the table is given daily earnings 20 to 40. It is in rupees. 5 shops, then 13, then 2, then 3 and 2. Frequency is number of shops. Then what is the probability that a shop earns first rupees 100 and more? We'll discuss these two questions later. Let's start with the first only. So number of shops. Let's start with the number of shops. So let's write number of shops is equal to 25. We want to find the probability of the shop that earns rupees 100 and more. Okay, so probability of the shop that earn rupees 100 and more. 100 is also accepted and more than 100 also we want to find. So first of all, let's find the number of shops. So in the range, we want to take more than 100, right? So 100 and 120. How many shops are there? You can see in the table, that is 2 only, right? So 2. And what is the total number of shops? 25. So that's the probability. Very simple. So probability of shops that earn rupees 100 and more is 2 over 25. Very simple it is. Let's move on to the next one. We want to find shop that earns at least rupees 60 but less than 80. Okay, so probability that rupees 60 at least and less than 80 as well, right? Okay, so means 60 to 80 only, that's our range, not more than that and less than that as well. So 60 to 80, how many shops are there? Again 2. So that is 2 by 25. Why 25? Because 25 is the total number of shops. Then third one, less than rupees 40. Okay, so here we need to get shop, probability of shop that earns rupees, let's write earn less than rupees 40. Less than rupees 40. Question mark. Okay, so less than 40. I believe there are 1 or 2 category. Let's see. So first is 20 to 40. How many shops? 5 shops are there only. Then 40 to 60. No, we cannot take it. We want less than 40. So there is only one category. So that is 5 and number of shops are 25. So 5 ones are and 5 fives are. So 1 by 5 is the probability. So probability of the shop that earned less than rupees 40 is 1 by 5. Let's recall what we did. First of all, take the total number of shops. That is 25. Given in the question, very straightforward. Nothing to bother about. There are 3 conditions that we need to find, 3 probabilities, rupees 100 and more. So 100 is also accepted and more than 100 is also accepted. So there is only one category, 100 to 120, that is 2 by 25. Then at least rupees 60 but less than 80, right? So 60 is the minimum range and maximum is 80. So 60 to 80, there is one category which has 2 shops. So that is 2 by 25. And the last one, shop that earn less than 40. So less than 40, there is one category, 20 to 40. How many shops? 5. 5 by 25 will give you 1 by 5 as the answer. Let's discuss one more interesting question. Let's start with that. 50 seeds were selected at random from each of the 5 bags of seeds and were kept under standardized conditions favorable to germination. Germination, right? We learned in science. After 20 days, the number of seeds were germinated, were counted and recorded as follows. So we have the table, right? Bag 1, 2, 3, 4, 5. 5 bags were there total. How many number of bags were there? 5 total. And how many days it kept? 20 days. So how many of them germinated? In first bag, 42, then 45, 48, 41 and 38 seeds were germinated. We need to find the probability for more than 40 seeds in a bag. Okay, first of all, let's write here, are we going to take total number of seeds or total number of bags are we going to take? This is very interesting concept over here because there are so many numbers given, and how to select that total and about which we are going to find the probability is very important. So the hint lies in the question. See, first of all, what is the probability of germination of more than 40 seeds in a bag and 49 seeds in a bag and less than 40 seeds in a bag? See, bag is the consistently used words, right? So we are going to take the total number of bags. Total number of bags, how many were there? So number of bags, how many? That is 5 only. See, in table also it is given, right? If we are not supposed to take the bag, then why there would be any table, right? So number of bags. First of all, we want to find more than 40 seeds in a bag. Okay, so probability of seeds more than 40, right? That we want to find. So how many bags are having number of seeds more than 40? You can see first, second, third and fourth. So how many bags are there? Total 4 bags are there. So 4 and total number of bags 5. So that's the probability 4 by 5. Very simple, right? We are only supposed to count the number of bags. Total number of bags are 5 and the number of seeds which should be more than 40, right? That is, there are 4 bags, right? So 4 by 5 it is. Let's discuss next one. So 49 seeds in a bag, 49 seeds. So let's write seeds is equal to 49. So how many bags are having 49 as the seeds? So in first one 42, then 45, 48, 41 and 38. Nowhere there is 49, right? So no bag, right? So we will write 0 number of bags over total number of bags as 5. So that is 0. What do we call this kind of probability? We learn in the introduction of this chapter. This is called impossible event because probability is 0 in this case. So this is impossible event. Next. So less than 40 seeds in a bag. Okay, so probability of seeds less than 40 is equal to question mark. Okay, less than 40. So there is only one bag, right? Reverse of this one basically. So there is only one bag which is having 38 seeds, right? So 1 by total number of bags, that is 5. So probability will be 1 by 5. So this is how we find the probability. This is very simple question, right? We have the data given to us. We just need to find the number of bags. Don't get confused between the number of seeds and the number of bags over here, right? We need to observe number of bags based on the seeds given over here, right? Bags which are having more than 40 seeds, there are 4 bags which are having 49 seeds, that is 0, impossible event. And bags which are having number of seeds germinated less than 40, that is only one bag. So probability is 1 by 5. Let's discuss next question. Let's do one more question now. So in a survey of 364 children aged 19 to 36 months, it was found that 91 liked to eat potato chips. So there are 364 children are there. So let's write number of children is equal to number of children is equal to 364, right? Okay, and 91 like to eat chips. Okay, so let's write here 364 and let's write those who like to eat chips are 91, right? This information is given and we have taken from the question itself. Okay, if a child is selected at random, then the probability that he or she does not like to eat potato chip is dash. We need to find the probability that if we select a child, if we select a child randomly, then what will be the probability that he or she will not like to eat the chip. So this is about the like. So do not like is, let's say here, how many children are there? 364. Out of that we need to remove how many? 91. So 91 it is. 4 minus 1, 3. Then here 16 and 2. So 16 minus 9 is 7 and 2 as it is. So how many children who do not like to eat potato chip is 273. Right, that number is 273. Total children are how many? 364. So we get the probability. You take the 273 by 364. That is the answer. So let's write probability of children do not like to eat potato chips is equal to, what will it be there? 273. So 273 it is, divide by 364. That's it. I think we cannot do any cancellation, so keep it as it is. If you want to get into decimal, you can go ahead and get the answer. So this was very simple, right? One information was given and we are supposed to find the probability about the information which is not given, but we can get indirectly. That is by subtraction of these two numbers, total 364 minus 91, so we get 273. So this is how we get the probability. Let's move to the next question. Let's do one very interesting question and important as well. It is about the property that we discussed at the start of this chapter. Let's start. A and B are the only two outcomes of an event. Probability of PA is 0.72. Done. Then what will be the probability of B and Y? Okay, so we need to find the probability for this, which is PB is equal to question mark. Now how to find this one? This is very interesting and easy as well if you understand how to do that. Okay, so let's start with the case of the coin only, right? For the coin, we know there are only two outcomes, that is head and tail. Now probability for the head is 1 by 2, we know very well, and for the tail is 1 by 2 as well. Now if you add them, you are going to get 2 by 2, that is 1, right? So if we do the sum of the individual probability of outcomes, we will get answer what? Always 1. The same concept we will apply over here, that 0.72 plus probability of B will give you always what? 1, right? This idea and this property we are going to use in this sum to get the probability of B. That's very easy, but you need to understand this concept very well. Same we can do for the die as well, that is 1 upon 6 plus 1 upon 6 plus 1 upon 6 plus 1 upon 6 plus 1 upon 6 almost 5 times. One more time, 1 upon 6 will give you 6 by 6, that is 1, right? Outcome of probability of getting number 1, then 2, then 3, 4, 5 and 6, right? That will give you answer 1. So that is this property we are going to use to solve this question. So let's start. So I can write here that probability of A plus probability of B will be what? 1. Now we have the value of probability of A, that is 0.72 plus probability of B as it is equal to 1. Let's shift this number over here. It will be negative. So probability of B is equal to 1 minus 0.2, that is 0.28. That will be the probability of B. This is very easy question, but you need to have a knowledge of this property. Then only you can solve this question. So this is how we find the probability of B, that is 0.28. Let's move to the next question. One important question and very interesting as well. We have discussed question related to this. We are going to use one of the property of probability. Let's start. The probability of guessing the correct answer to a certain question is x by 3. Okay, so for correct answer probability is what? X by 3. So far, we were not given any kind of probability, right? We were just finding the probability for what question it was. This is the case of reverse question, right? And if the probability of not guessing the correct answer is 5x by 3, then find the value of x. Okay, so first of all, let's write the information that's given to us. So probability of correct answer is what? X by 3. Okay, and for the incorrect answer is incorrect answer is 5x by 3. That's the probability, right? We need to find the value of x. So how shall we proceed? Remember, we discussed one question where we discussed the property of this probability. Like I told you, that probability of getting, when we toss a coin, for head it is 1 by 2 and for tail it is 1 by 2, and when you add them up you get 1. So this property we are going to use it. Probability of getting the correct answer plus probability of getting incorrect answer is equal to what? 1. So let's start with that. So probability of correct answer plus probability of incorrect answer is equal to what? 1. So this is an equation. Now let's substitute the values. So x by 3 plus 5x by 3 is equal to 1, right? This is linear equation in one variable. So let's solve it. Here see x by 3, x by 3. So what will it be? Right here 1. So we can write x plus 5x by 3 is equal to 1. So 6x by 3 is equal to 1. 3 1s are, 3 2s are. So here it is 2x is equal to 1. So x is equal to 1 by 2. That's the value of x. Very simple question it is. When you read the first time you get confused how to find the value of x. But if you use the property of probability, then it will be easy to solve it, right? We have probability of correct answer, probability of incorrect answer is given. Now we add probability of each outcome, right? Then we are going, and then we add up, we get answer 1. So x by 3 plus 5x by 3 is equal to 1, and you need to solve the equation in one variable, that's x is equal to 1 by 2. So what we studied in this chapter? Probability. This year we study about the experimental approach, right? We do something for number of times, let's say 500 times, 100 times, then we note down the outcomes. Let's talk about the case of coin only. 100 times if we toss the coin, we note down the readings, that what are we getting, head how many times we are getting, and tails how many times we are getting. Then we apply the formula. So this year probability was about experimental approach. Then we discussed different cases for coin and for dice as well, and miscellaneous problems that we come across in the daily lives. So this was chapter number 15, probability, and this was the mathematics of grade 9.